All right, welcome back. Today, we are going to tackle one of the most fundamental, most important pieces of the entire internet, the web crawler. I mean, this is the engine that works behind the scenes, making everything searchable. So let's pull back the curtain and figure out how this thing is actually built from the ground up.
So let's just start with this absolutely massive question. How does a search engine find and index over 100 billion web pages? I mean, seriously, when you type something into that search bar, you're tapping into this gigantic library. How on earth does any system even begin to find all that stuff? Well, the answer? It's the web crawler.
So what exactly is a web crawler? The easiest way to think about it is like this. It's the internet's digital librarian. Now, obviously it's not a person. It's a program, a piece of software. And its entire job is to just systematically go through every corner of the web, read what it finds, and bring all that information back so it can be organized.
Okay, so here's the more technical definition. A web crawler, you'll also hear it called a spider, is basically a bot. It browses the World Wide Web, kind of like you do, but its whole purpose is to download pages so that search engines can index them. You know, it follows one link to another, and in doing so, it maps out the entire vast web.
All right, so how would we actually build one of these things? Let's start with the absolute basics. You know, the core mission. Before we even think about billions and billions of pages, let's just figure out how to crawl, like, a handful. We're going to start small and build our way up from a single step.
So here it is. This is the basic blueprint, the MVP, the minimum viable product. And this is the fundamental loop of any crawler, whether it's big or small. You start with a seed URL, just one. You download that page. Then you extract all the links you can find on that page. You add those new links to a list, a to-do list basically, and then you just repeat, forever. That's the core engine right there.
I mean, it really is that simple at its core. Just a four-step loop. 1, get a URL from your list. 2, download the content of that page. 3, extract all the new links. And 4, add those new links right back to the list. That's it. This simple cycle, when you scale it up and repeat it millions of times a second, well, that's what maps the entire internet.
Okay, but that brings us to the real challenge, doesn't it? That simple loop? It's great for a tiny project. But how in the world do you scale that to handle billions of pages? How do you manage a to-do list that has billions of URLs without the whole thing just crashing and burning? This right here is where we stop talking about a simple script and start talking about real, hardcore system design.
See, to handle that kind of scale, you can't just have one program trying to do everything. It's just not going to work. What we need is a distributed system. Think of it like a team of specialized components, all working together. So let's build this machine piece by piece.
First up, component number 1, the URL frontier. You got to understand, this is the heart and the brain of the whole operation. This is not just a simple to-do list anymore. No way. This is a highly intelligent, super sophisticated, prioritized queue that has to decide what single URL to crawl next out of billions of possibilities. Okay, next up we have the downloader fleet. Think of these as your workhorses. They're an army, a huge number of simple little programs, and they have only one job. Take a URL that the frontier gives them, go out onto the web, and fetch the raw content of that page. That's all they do, but they do it millions of times.
So, once a page is downloaded, where does it go? It has to go somewhere, right? Well, it goes into the content store. Just think of this as a massive, practically infinite storage locker. Something like Amazon S3 is a perfect example. It's where all the raw HTML from all those billions of pages gets saved so we can process it later.
And finally, our last major piece, the URL extractor, or what we usually call the parser. This component's job is pretty straightforward. It takes that raw HTML we saved in the content store, reads through it, and its whole goal is to find all the new links hidden in that page. And what happens to those new links? They get sent right back to the URL frontier, and that completes our big scaled-up loop.
Okay, so we've got our components. We have the blueprint. But now we have to solve the really hard problems. The kinds of problems that separate a little toy crawler you'd build in a weekend from a massive production-grade system. This is where you really start to think like a senior engineer, moving from just theory into the messy, complicated reality.
All right, challenge number 1. That URL frontier, it needs to be way more than just a list. It has to be smart. It can't just be a simple first in, first out queue. It has to make decisions, like which pages are more important to crawl first. And, this is absolutely crucial, it has to be polite to the websites it's visiting.
So how do you solve that? Well, the industry standard solution is actually pretty elegant. Instead of one giant queue, you use multiple queues, one for every single website domain. Then you have a scheduler component that intelligently picks which domain's queue to pull from next, and it does this based on a set of politeness rules. This design is great because it also makes prioritization super easy. You can just tell the scheduler to check the queues for more important sites, like news sites, more often.
And that brings us to what might be the single most important concept in all of web crawling: politeness. I mean, think about it. You're sending millions, maybe billions of automated requests to other people's servers. Being a good citizen of the web, it's not just a nice to have, it is non-negotiable. You get this wrong, and your crawler will get blocked instantly. Game over.
So how do you make sure you're a good bot? It really comes down to 3 key things. First, you absolutely have to obey a file called robots.txt. It exists on almost every domain, and it's a set of rules telling you which pages you're allowed to visit and which ones are off-limits. Second, you have to implement strict per-domain rate limiting. That just means you don't hit the same server over and over again, maybe just one request every 5 seconds or so. And third, you use a clear user agent string to identify your crawler so that website owners know who's visiting them.
Okay, on to our next huge challenge: duplicates. The web is messy. It's full of duplicate content. You have countless different URLs that all point to the exact same page. And crawling the same page twice, or 3 times, or 100 times, that is a colossal waste of resources. We're talking time, bandwidth, storage, money, all of it.
Now, the naive way to deal with this would be to just check every single new URL against a massive database of every URL you've ever seen. But can you imagine how slow that would be with billions of links? It's just not feasible. So, the smart, scalable approach, the one the pros use, is a 2-level check. You do a super fast maybe check first, and then, only if you have to, you do a definitive check with a more persistent set.
And that super fast first pass check, it's usually done with a really clever data structure called a Bloom filter. Now, you don't need to get lost in the computer science weeds here. All you need to know is what it does. A Bloom filter is an incredibly fast, memory-efficient way to answer one question: have I possibly seen this before? The key is that it can have false positives, but never false negatives. So if it says no, never seen it, you know for a fact it's new. If it says maybe, then and only then do you do the slower, more expensive check. This little trick saves an absolutely massive amount of work.
All right, so there you have it. We've designed a powerful, scalable web crawler. Now let's wrap this up by condensing everything we've talked about into a kind of cheat sheet. These are the key talking points you'd want to have in your back pocket if you ever had to explain this system, say, in a job interview. So here are your key takeaways for that interview. First, you're going to frame this whole thing as a big data pipeline. That's the right language. Second, you have to talk about the frontier being the brain of the system, and you need to explain its complexity, the prioritization, the politeness. Oh, and always, always be the one to bring up politeness. It's a huge green flag. Fourth, you want to address duplicates using that 2-step Bloom filter and set solution. It shows you know the scalable patterns. And finally, just emphasize that all these components, the downloaders, the parsers, they're not single things. They're distributed fleets built for insane scale. And there you have it. That is how you design a web crawler. We've essentially built a machine that can go out and discover and download the entire internet. But, that just leads to the next, maybe even more interesting question. Once you have all that data, all 100 billion pages, how do you decide which ones are actually important? How would you rank the web?